It's time to grab your cosmic guidebook. We're setting off on a journey across space, this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. What if you could flip open a travel guide and set off, not to Paris or Denver, but to Saturn's hexagon, the icy oceans of Europa, or the craters of Mercury? This week, I sit down with adjunct scientist at the Max Planck Institute for Astronomy in Heidelberg, Germany, Mark McCaughrean. He'll talk about his new book, 111 Places in Space That You Must Not Miss, Your Portal to the Universe. It's a cosmic tour guide filled with breathtaking images, wild stories from missions like Hubble and Rosetta, and a reminder of why our home planet still matters most. We'll take a journey across the solar system and explore how imagination and science meet space storytelling. Then we'll check in with Bruce Betts, our chief scientist, for another installment of What's Up, as Bruce talks about the next 2 installments of our Planetary book series for kids, one of which is out now. If you love Planetary Radio and want to stay informed by the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Before we get into our cosmic tour, I want to take a moment for some breaking space news. Last week, NASA announced that a rock core collected by the Perseverance rover in Jezero crater may contain a potential biosignature, a chemical pattern that could point to ancient microbial life on Mars. The sample, which is nicknamed Sapphire Canyon, was drilled from a rock called Chayava Falls in the Bright Angel Formation. The first hints of this story emerged last year, but now a peer-reviewed Nature paper has deepened the evidence, marking one of the most compelling astrobiology discoveries to date. A potential biosignature doesn't mean we've found life yet, but it's the kind of evidence scientists have been hoping for. We'll dedicate an entire episode to this story in 2 weeks, when I'll be joined by the study's lead author, Joel Hurowitz from Stony Brook University. And from the search for life on Mars to a journey across space, let's turn to this week's main story. Dr. Mark McCaughrean has spent decades at the heart of space science. He earned his PhD in astrophysics from the University of Edinburgh and went on to work at NASA's Goddard Space Flight Center, the University of Exeter, and several major European research institutes. Until 2024, he was the senior advisor for science and exploration at the European Space Agency, where he helped guide and share discoveries from missions like Hubble, Rosetta, Bepi Colombo, and the James Webb Space Telescope. Today, he continues that work as an adjunct scientist at the Max Planck Institute for Astronomy in Heidelberg, Germany, contributing to JWST's science returns and helping to connect the public with the human adventure of exploration. His newest project is a book called 111 Places in Space That You Must Not Miss, Your Portal to the Universe. It's part of a long-running international travel series that usually highlights hidden gems in cities across Earth. But this is the first volume that sets its sights beyond our planet, transforming the format into a cosmic guidebook. Each of its 111 chapters introduces a remarkable destination, from the Apollo landing sites on the moon to Europa's hidden oceans, the cliffs of comets, the pillars of creation, and even the afterglow of the Big Bang. Each location is paired with gorgeous images from space telescopes, planetary missions, and even amateur astronomers. Of course, we can't possibly fit all 111 of those destinations into a single podcast episode. But in our conversation, Mark and I will set out on a highlight tour, stopping at some of the solar system's most fascinating worlds, explaining how imagination and science can work together to bring the cosmos closer to everyone, even people who just randomly picked up a travel guide. Here's my conversation with Mark McCaughrean. Hey, Mark, thanks for joining us.
My pleasure. Nice to see you.
You've worked across some of the most exciting missions and institutions in modern space science through ESA and NASA, and now the James Webb Space Telescope. I feel like there's so many things we could talk about, but today we're going to be talking about your new book and maybe taking a mini tour of the places in space, at least in our solar system, that we shouldn't miss. It must have been a lot of fun writing this.
Yeah, definitely. You know, it's a little bit like being a teacher or a professor at university. There are so many of the places in the book, of course, that I have not studied myself. But if you teach that material, and I, was a university professor before, and you really have to get up to speed on material that you don't know from your own research or from your own experience. On the other hand, it's changing all the time. And that was sort of one of the great nightmares in a way, was that the science is constantly moving. I mean, as a trivial one, the number of moons that Saturn has suddenly changed halfway through the writing of the book. But you've got to draw a line at some point. It's got to be finished, and that's it. And JWST, you mentioned that. There's a lot of images in the book from the Hubble Space Telescope, which has been producing amazing images forever. And I worked on Hubble as a postdoc at the University of Arizona. That was before the launch of Hubble. And everybody knows, of course, Hubble had problems with its optics when it was launched in 1990. In a way, although that, of course, caused problems for many people, including me. I mean, many people on the project lost our jobs with like 6 weeks' notice. But if that hadn't happened, I wouldn't have moved to Germany. I wouldn't have been here at the right time to then get involved in JWST. So, fate has a way of dictating these things. But with JWST, there's, new pictures every week coming out. And again, I had to sort of draw a line and have a balance. And I think the other thing that's worth saying before we go into any detail is that for all that there's lots of great pictures from space missions and space telescopes, there are quite a few pictures in there that have been made by amateur astronomers using small telescopes on the ground, or people, and of course there's some amazing pictures on the Planetary Society's website, which I've taken and used, people taking data from the archives of various space missions. So I'm deeply indebted not only to the people that built the amazing, big missions, but also the small scale stuff that's going on, producing astonishing pictures.
Well, this book is part of a larger series that focuses on traveling to places on Earth. But this is the first one in the series that totally leaves that space and goes into outer space. How did this idea of this book happen? And did you reach out to the publishers, or did they come to you?
No, it worked exactly the opposite way. They came to me. As you say, it's a series of books published by German publishers, Emmons Verlag in Cologne here in Germany. But they have books in German, but then they have a whole other range in English. And it might be, well, I live in Heidelberg in Germany. So if you're going there, you might say, well, let's pick up the book that says 111 places that you must not miss in Heidelberg. And a little bit, they're supposed to be out of the way places. It's not supposed to be the classic tour guide where everybody goes. Of course, you can have a mix. And there's also this sort of little trope which you have to follow when you write one of these books, that you have the main chapter of 300 words or so, then you have the picture, and at the bottom of the picture, there's all the information about how do you get there, which bus do you take, what are the opening hours. And that sort of started setting a big challenge for me. What do I put down for the address for these places? But also there's this thing which is at the bottom, imagine you went to a museum to see, Iron Age chariots, and then you come out and then, there's a tip at the bottom of the chapter says, and there's a brilliant ice cream shop just around the corner. Go and get a lemon sorbet from there. So I had to do that too. So for all of the 111 places in the book, there has to be somewhere else a tip. And of course, sometimes they're not allowed to be in the same place. So if your chapter's about Mars, the tip cannot be on Mars. I mean, it's the structure of the book writing. So they've got hundreds of books in this series. And as you say, they're classical tour guide books. But the origin of the book comes from the editor, Karen Seeger. The story goes, and this is before I met her, she was on an airplane and traveling somewhere. She's American, but was living in Paris. And she watched the film Hidden Figures and was so taken with that film, and then suddenly thought, you know what, we need to commission a book which is about space. So yes, the connection for Karen to then go and look for somebody who would be able to write this book was through Bert Ulrich from NASA headquarters, who was in charge of all of the branding work that was done there. So if a film wanted to use NASA logo, or a T-shirt company wanted to print it on its shirt, you'd have to go to Bert. And I knew Bert through some work we had done on some shows with Apollo astronauts where we had been traveling together. And I will say there were some points in the writing of the book where struggle is too strong a word, but there was a slight challenge in as much as, you need to write it as a tour guide. You need to write it the way you would as if you were going to a city and arriving somewhere and seeing something. And of course, we don't typically do that outside the solar system, certainly not. We don't go to these places, we look at them from afar. So there's a little bit of fantasy element in the book about, you arrive at this galaxy. And there are some where, I say, well, we can't arrive at the cosmic microwave background. It doesn't make any sense. It's everywhere. It's around us. We can't go to it. And so there were sort of push and pull a little bit on, you need to indulge the fantasy a bit. But hopefully we got there without, again, indulging too much in the fantasy of, imagining that you've got a spaceship which will take you wherever for free and there's no consequences. So seeded in the book very much is the idea, well, you won't actually be able to go to these places, but if you could, it put constraints on me in a way, in a kind of disciplined way.
Yeah, sometimes you just got to get in that spaceship of the imagination and travel. But I do like that you seeded those little moments in there. Like, you could do that, but you'd have to suffer the consequences of doing so relativistically.
Yeah, no, indeed. I mean, there's nothing to say that you couldn't go to the Andromeda Galaxy. If you could go fast enough, in your timeline, you could do it, in days. But the rest of the universe has aged around you immensely, and you couldn't come back. So, and I think there were, there's not much room within each chapter because, in essence, each one is supposed to be read in isolation. It's not a book, at least by design, you don't start at the beginning and get to the end. So you can't seed the ideas in people and kind of build up in a way a textbook or a popular astronomy book would. But if you dip into enough chapters, you say, oh, well, that thing, now I understand that because it was over there in that chapter. And hopefully some of the things mesh together. Even the concept of traveling across the universe and going to places that in essence don't exist anymore because we see them as they used to be. It's taken billions of years for light to get to us. We look at them. If you say, well, let's go there. Well, it may not be the same object at all anymore. It's a supernova. It may have blown up, or a whole galaxy may have merged with another one. And people, I wouldn't say people struggle with that, but they get very confused when you talk about looking at the youngest galaxies in the universe, which are the ones furthest away from us, and it's the ones that's taken light the longest to get to us. Why are they not the oldest galaxies in the universe? Well, we're seeing the baby pictures, which were stuck in an album when the galaxies were young, and it's been in the post a long time. So you're only seeing them as their babies. You have no way of seeing them as grown-ups today.
That's part of what's so fun about using this kind of travel book as a mechanism for getting people into this, because you do have to take it back down to that level, because this might be people's first exposure to these places.
Yeah, I think that's very important, right? I mean, the other books in the series will be for somebody who is going on holiday to Heidelberg or to Denver. You have a purpose in mind. Here, it's for anybody because, there's no specific location. Of course, they may be interested in space. Some people may come with it some prior knowledge. But I hope at least that it can, through the pictures, essentially, because it's full of beautiful pictures. But hopefully in this book, all the images convey something beautiful and mysterious. So you're being able to talk to people that really haven't engaged in this topic before, because they might find it on the shelf next to Heidelberg or Denver. They go, oh, what's this one?
I think the greatest challenge of writing this book, except for all the things you've just mentioned, was probably just trying to narrow it down to 111 places. I mean, how did you go about deciding what you wanted to add to this book and leaving other things out? Honestly, I would have the hardest time.
Yeah, no, precisely. I mean, I didn't look at any previous work. It was simply, what can I think of from my own experience as an astronomer, and having worked at the European Space Agency on many of planetary missions and others. So I kind of came with enough high-level experience on space missions and telescopes to sort of say, well, we got to go from here to here, right? From the sun to the cosmic microwave background. But as you say, there's way more places in between than just 111. I did initially sort of think of, structured it in my mind, at least, of doing that from the nearest or the center of our solar system all the way to the edge of the universe. The book is not structured like that for the reason that, again, the way the books are normally written, you go to Denver, the 111 places are ordered alphabetically. So you might have a complete mishmash of things at very large distances, things very close by. We did agree in the end to break it down into the solar system, the Milky Way, and then the rest of the universe. So at least at that level. But then they're ordered alphabetically. So, it might seem a bit jumbled. But again, you're not supposed to read it kind of from the beginning onwards. It's dipping into it. So I think to begin with, it was easy to say, well, I'm going to include Mercury. I'm going to include Venus. I must admit, I did have a struggle to persuade the editor to include the Earth. Her view was, no, this is a book about everywhere else except the Earth. And, the Earth is a planet. The Earth is in space. I think comparative planetology, what's the Earth like relative to Mars and Venus, warrants having the Earth in the book. But also, I really felt very strongly about talking about the Earth as the place we're from, the place we live, and the place we're trashing, the place we maybe are dreaming of leaving to go somewhere else. But no, this is the pale blue dot. This is the, to paraphrase, and I do paraphrase Carl Sagan in the book, this is the only place the only home we've ever known. And it probably will be the only home we know for a long time. We may have some adventurers that go to places, but, at least in foreseeable future, we're not going to go and live en masse in the stars. That's not happening. Maybe a bit in the solar system, although even there, I'm not completely convinced that that's very wise. Humans are made for this planet. So I wanted to include Earth from that perspective. But so, initially, and of course you include the Andromeda Galaxy and you include the Orion Nebula. They're kind of the obvious places. But then as you start thinking about what else shall I include? Firstly, you want to tell different stories. There was a point where the worry was that I was just going to fill the third part of the book, Deep Space, with just yet another galaxy, because they're all distinct locations. I mean, again, there was this restriction. You can't have two places to visit in the same place. It's like, well, hold on. If you can have 111 places in Denver, then surely I can have 10 places on Mars. But no, the rules of the book. And I worried that if it was just another galaxy, I would end up saying the same thing each time. So then I began to think about it in terms of the stories from physics, from space science, from planetary science that I wanted to tell. What's the evolution of the solar system? How was it put together? What can we learn from our planetary system? How are stars born in the Milky Way? How does gas and dust come together? How do planets form around stars? How do stars live? How do they die? So that began, I think, to then say, well, I've got to include a Cepheid variable because I'm going to talk about the distance ladder. How do we know how far things are away? I've got to include an interacting galaxy pair because I want to talk about the possible merger of the Milky Way and Andromeda and the way that galaxies are built up. And then I had exactly the problem you mentioned. Then it went from being 50 to 250 very quickly. Which one am I going to throw overboard? And I struggled with every one because they all had a kind of a unique story. And possibly in the end, it came down to which one had the better picture.
Well, while I have you, let's actually take a little bit of a tour through at least the planetary parts of this book. There's so much in here that we could go on forever. And as someone who studied astrophysics, I would love to get into the deeper space parts of this. But you actually start with the moon. And specifically with the Apollo 12 landing site. Why did you go with Apollo 12 instead of, say, Apollo 11 or any of the other ones?
Yeah, no, it's great. It's great. I mean, the reason it's first in the book is purely alphabetical. So because Apollo, so it wasn't chosen to start the journey there. But once I knew that everything had to be alphabetical, I had to break away from any kind of narrative which led you starting at the sun, which is what you might normally do. But why Apollo 12? Well, partly for two reasons, really. One, because there are some fantastic pictures from the Indian Chandrayaan mission looking down at exactly the right time of day when the sun is on the horizon from the perspective of the moon and casts very long shadows of Apollo 12 and also of other bits and pieces around the lander, the launch stage, which is still on the surface, of course. And similarly, you can see very clearly in that Apollo 12 image footprints. You can see the route that the astronauts took. And Apollo 12 in particular, because they landed very close to another spacecraft. Uniquely, they landed next to Surveyor, one of the Surveyor missions, which had landed there a few years earlier. And I love that idea because, again, this is a tour guide, right? Why would you go to visit Apollo 12? You get the Apollo 12 astronauts themselves had already done the same thing. They had gone to a place where there was something interesting to see. A previous robotic lander that had been on the surface for a while. One of the things which I mentioned in the book is that, now the Apollo landing sites themselves, all of them, they need complete protection because there will be humans going back to the moon. And these are historical sites that should remain untouched. Those footprints will last for maybe millions of years. And yet the Apollo 12 astronauts went over there with a crowbar, essentially, and cut bits off Surveyor. So to bring it home, to look at how the material had, been weathered by being on the moon for that. So it was a legitimate thing to do, I think, sort of engineering and science-wise. But now that balance about protecting those sites as, they're astonishing pieces of heritage at the level of the Taj Mahal or anything you could think of on planet Earth. Those Apollo landing sites absolutely have to be protected.
Really, though, I do worry that we need to put these systems in place to protect these things, because one of these days, hopefully, space travel is going to be way more accessible, and suddenly we're going to have space pirates going and picking up Ingenuity off of Mars.
But no, you're absolutely right. I mean, at some point, and people are discussing, there are lots of people that have this discussion about how we should be protecting these sites in space or satellites out there. For example, if somebody decided to go tomorrow as a private astronaut, and it's not beyond the realms of possibility, and fly to the Hubble Space Telescope. There's been this discussion about doing this as a mission to lift Hubble to a higher altitude to stop it from burning it up in the atmosphere. But I won't get too deep into that. It's mostly on the US side, but there's a real tension between NASA, it feels to me at least, between NASA and SpaceX about doing that as a private mission, because, where does the responsibility lie if something goes wrong? And I think, that discussion is being had in a very good way, but we're not that far away from people just doing irresponsible things. The more and more we go into space, the more and more people there's always going to be a rogue element there, and I think we need to be aware of that.
Well, this is not something you did intentionally, because it's a feature of the alphabetical nature of this book, but you go from our moon all the way out to Arrokoth, the most distant object we've ever sent a spacecraft to, at least close by. And I love how that kind of just takes us immediately into the scale of our solar system. That's so interesting that just kind of happened by happy accident.
Yeah, I mean, I was aware of it when it happened. So I looked at exactly as you say, right? That sort of the closest thing and the most distant thing that we've been to. And Arrokoth was one of those images where the photo editor said, "Oh, it's a bit fuzzy." It's like, well, it's the first Kuiper Belt object we've flown past, if you discount Pluto and Charon themselves. But yeah, no, I think the idea of that juxtaposition from near to far worked out very nicely.
Well, then we can go back down into the solar system, closer to the sun. We'll skip over the sun for now and go to Mercury. In this book, you call it the solar system's problem child. Why is that the way that you describe this world?
Well, it's still a mystery. We've only really had a flyby and one orbiting messenger, and now ESA's Bepi Colombo, ESA and the Japanese Space Agency JAXA, is on the way there with Bepi Colombo. And Mercury in orbital dynamics term, flight dynamics term, is actually harder to get to than Pluto. So we just talked about Arrokoth and New Horizons. And you would think Mercury's easy to get to. It's close by, relatively. It is, and you can get there quickly if you want to, but stopping is a whole other thing, because, of course, you're going towards the center of the solar system, and you've got to get rid of all of that orbital velocity. And so Bepi Colombo is doing all these flybys. It's been to the Earth, and it's been to Venus, and it's had flybys at Mercury itself 6 times. And at the end of next year now, it should arrive. But then it's that question, why? What's so exciting about this little hot rocky ball? It has some weird properties. It's very dense. It's denser than the Earth. It's rocky, but it's got more metal in it, essentially, or a higher metal content. It has a magnetic field, which it shouldn't, because it's too small. Is the sort of prevailing thinking. The smaller a planet is, the quicker it can cool over cosmic time. 4.5 billion years ago, when the solar system was formed. If you're a small body, you've got lots of surface area, you cool quicker, and your core will solidify in that length of time. So you won't have liquid metal in the middle, which can make a dynamo, which can then make a magnetic field. And yet Mercury has a global magnetic field. Why? What happened to it? So there are all sorts of ideas that maybe Mercury is the remnant of a big collision, or maybe that it was formed somewhere else in the solar system and has been migrated into where it is today. And the other thing is, the surface of Mercury is at around 450 degrees Celsius. I'm not going to attempt to convert that into US units, although the book does. So don't be frightened about buying the book if you don't, I was lucky I was allowed to use kilometers and kilograms and degrees Celsius first, but all of those are translated into imperial units, Fahrenheit, miles, and pounds. So it's 450 degrees Celsius, and to put that in context, that's the temperature of a pizza oven. So if you go out and have that pizza that's cooked in just a minute in that huge wood-fired oven, that's the temperature inside. And yet Mercury has on its surface volatiles. It has potassium and sodium and stuff kind of bubbling out or on the surface. Where's that coming from? That should have all been blasted away by the intense heat coming from the sun. And at the pole of Mercury, we know that there's water. There's water ice. Now, the beauty about Mercury is that its axis points kind of straight up, if you like, perpendicular to its rotation around the sun. On Earth, we know it's tilted at 23.5 degrees, so you get sunlight at the North Pole in summer, and you get sunlight at the South Pole. But that doesn't happen on Mercury because there's no tilt or very little tilt. And so you can have incredibly cold temperatures on Mercury in a crater. And maybe that water ice came from a comet or being deposited on the surface. So there's so many mysteries about Mercury. It just kind of doesn't fit. And yet, if you want to create a model, a theory of the birth of the solar system and the evolution of the solar system, you can't move the problem child out of the picture. They have to be in the picture, and Mercury's that child. There's lots of other problems in the solar system to solve, but Mercury is a weird one, and that's why it deserves having its own mission. Bepi Colombo going back now and Messenger did amazing things, but it didn't spend a huge amount of time close to Mercury. I mean, it did fly by and then go further away, but Bepi's going to be at a few hundred kilometers above the surface, getting constantly baked by the sun on one side, by Mercury on the other side. It's an incredibly challenging mission. And, my colleagues, we'll see when we get there, right? But that's what we do in space science. There's no point doing the boring things, the things we've done already. Let's go and do something new and challenging.
I always tune in for Bepi Colombo's flybys of places as it's going. I cannot wait until we have another dedicated mission there. But then we go out to a place like Venus that in and of itself does not have enough dedicated missions. We're looking forward to ESA's Envision mission getting there. The United States NASA missions are very much up in the air right now, Da Vinci and Veritas. But this world has such a thick atmosphere. It's a hellish place. We have landed on the surface, but it is so challenging to study. And you do manage to get at least one very specific location in there, Mont Mons, which might potentially have some volcanic activity. But do you feel like there were places on this world that you wish you could have investigated further, but we just didn't have enough information about them? Oh,
completely. I mean, Venus, there is a historical element to the book in the sense that, I tried, if there's a story to be told about the history, then you'll find William Herschel discovered pretty much half the universe in the book. So having a big telescope at the right time. But then, you found people in the 1800s who were discovering the first asteroids, and they were doing it from their apartment in the middle of Paris, looking up at the sky with a small telescope and discovering things that hadn't been seen before. So there is some history in there. We have to remember that it's really certainly less than a century ago that people thought that Venus was basically a swampy planet. It was a bit warmer than here at Earth, and all those clouds that you could see were just sort of covering a jungle, and maybe there was life there. And then with the space missions and the infrared observations, it began to realize, no, it's awfully hot there, and then that's wrapped into the greenhouse effect. It's even hotter than Mercury, despite being further away from the sun. It reaches more 460, 470 degrees on the surface. And the density of the atmosphere is just astonishing at the surface. I always forget the numbers, but it's a kilometer deep under the water. That's the pressure, the atmospheric pressure. And yet, as you pointed out, the Soviets landed missions on the surface and took pictures. And I did want to get those pictures in there. They were, again, very low resolution. They've been beautifully reworked by some people looking through the telemetry streams and sort of taken out that distortion from the way the cameras were looking down. As you say, with Mont Mons, this is a discovery which is relatively recent, that there have been hints of active volcanism on Venus from thermal imaging of the surface from Venus Express, for example, an ESA mission, and you could see places which were hotter at the top of some of these volcanoes. I mean, Venus is covered in volcanoes. There's volcanoes everywhere. But were they active? So there were hints of that being the case. And then more recently, people have gone back to the Magellan radar images, which were taken in the 80s. And they were taken over a long enough period of time that if you compare two images of the same location, it's been seen, you can see lava pits opening and lava flows running down the surface on Venus. And I think that's astonishing. I suppose it's volcanism is actually, it features all over the book. It's everywhere in the solar system, volcanism. But that's this is a discovery, again, using archival data. Make sure your data are available. Don't delete the data. But there's, so many questions to be answered still about Venus because of the brevity of those landing missions, but also going back again and radar imaging the surface in even more detail, compare it to the way it was 30 years ago, 40 years ago. I mean, I think there's a lot to be done. And then there's this whole business of the atmosphere as well. There's a point in the atmosphere where the temperature and the pressure are, pretty decent. You can fly a balloon there. You'd have to breathe oxygen. There's no oxygen to breathe, but you wouldn't be an unhappy place for a human being in terms of temperature and pressure. And then, of course, this suggestion, this very controversial discovery going backwards and forwards on phosphine in the atmosphere of Venus. And is that a tracer of life? Is it in the data to begin with? And could it be life there? So there's been that little bit of resurgence.
We'll be right back with the rest of my interview with Mark McCaughrean after this short break.
Hi, I'm Danielle Gunn, Chief Communications Officer at the Planetary Society. We're proud to support International Observe the Moon Night, NASA's annual celebration of our nearest neighbor in space. This event brings together skywatchers, families, students, and communities worldwide to share in the wonder of the moon. Whether you attend a local gathering, host one yourself, or simply step outside to look up, you'll be part of a global movement to connect with our moon. International Observe the Moon Night takes place on and around Saturday, October 4th. Explore activities, download custom moon maps, and find events near you at moon.nasa.gov/observe. However you choose to participate, outdoors, online, or from home, you're invited to celebrate the moon with the world.
Then we move on to Mars, which I think personally would be the most difficult place to figure out what locations to talk about. There is so much going on that planet, but I think it's really interesting that you took the time to include the so-called face on Mars. And in that description, you get into, the fact that when you look at it from different lighting conditions and things like that, it's not the way that people thought it might be. And you actually reference Carl Sagan's book, The Demon Haunted World, and caution people about jumping to conclusions in these space situations. But I think it does point to this tendency that humans have to project ourselves onto these completely alien situations.
Yeah, I think there's a risk of being a little polemic about these things. And, from the fantasy perspective, don't tell people you can't go to these places or why you shouldn't go. But I'm a scientist, and I think there is a degree of credulity about things. And some of that might be wishful thinking. People want to explore, people want to find things. Some of that, I think, maybe not so much in astronomy, but in other fields, some of that's deliberately stoked in order to create uncertainty and controversy. And so, we live in times where science is used as a way of running the world, if you like. I mean, it's a methodology which allows us to have the astonishing technology where we can talk across Zoom, across the Atlantic, and across thousands of kilometers. And yet, some people want to tell you that's not how that doesn't work. The Earth is flat. Let's take that as the classic one. And Sagan's book, The Demon Haunted World, for me, is his definitive book on this topic. And you've seen it. I'm sure everybody who's on social media is seeing quotes from that book in a much more modern context. And there were so many things he wrote in that book, which I think are still resonant today. They're universal stories about humans and how humans tell stories. The face on Mars was an interesting one because, of course, it has happened during my lifetime. And there was this whole idea, aliens on Mars but some of that precedes, the story of Barsoom and the fact that Mars could be a place with canals and water and civilizations and so on. So it fits into that narrative. And some of that narrative is established by our space missions, the ones that have gone there. So that first picture, which shows from a particular lighting angle with very fuzzy pixels, or maybe that's a face. But then people immediately looked around in the data and said, there's pyramids here. And there's guys, slow down. But even with the more modern missions, all of the astonishing pictures being taken by the rovers, by Curiosity and Perseverance, and by the smaller rovers as well, Spirit and Opportunity, and so on before. There's a sunset. You're in a desert. It's a beautiful sky. Could you imagine yourself standing there? For me, and I have to be a little bit careful about not misquoting him, but Steve Squires, who was the PI of Spirit and Opportunity, And I had met him actually, weirdly, many, many years before when I was a young PhD student, and he had just applied to become a NASA astronaut. But he came to where I worked in the Netherlands more recently, probably 2010 or so, and gave a talk, beautiful talk about the results from Spirit and Opportunity. But he said very clearly, who would want to go and live on Mars? It's a hellhole. I mean, why? I mean, it's fantastic to send your rovers there and maybe the occasional astronaut to do particular kinds of science. Why would you want to live there? He certainly didn't want to. So I think that chapter about Mars, as you said, I did say, how many places can I have on Mars? Because I could fill the whole book on Mars. And that became one of the debates. What do you mean only 2? You've got 111 places in Denver. You can at least have more than 2 places on a whole planet. But I got it. It's the discipline of the book. So picking a chapter with the face, I think it allowed me to tell another story. It's not just another canyon, not just there's a chapter about Olympus Mons, the most astonishing volcano in the solar system. But I wanted to keep that chapter about the face because it allowed me, hopefully in a reasonable way, to tell that story about the credulity of believing that we're all just going to become a spacefaring species that's, multiplanetary, all the buzzwords we hear all the time from the new space area. It ain't that easy, technically. And B, none of these planets are going to love you like the Earth does. As much as you might abuse the Earth and trash it, this is the place we come from. And as and I'm not the only person to say this, it doesn't matter what we do to this planet. All the bad things we could do, nuclear war, runaway global climate change and so on, it is still going to be more habitable than anywhere else in this solar system. So this sort of fantasy idea of escape and is wrapped up in manifest destiny and all these things as well. Listen to Carl, read Carl, and he's still pertinent today. But of course, we're then accused of, I find this, I had this in social media and elsewhere, you're a fuddy-duddy, you're a curmudgeon, you're only thinking, how will we ever do these things with your kind of thinking if that you're a Luddite? It's like, no, not really. I'm a space scientist. I love this stuff. But there's a phrase which I use quite a lot. It's not mine. I don't know who to attribute it to. But the phrase is, it's one thing to have an open mind, but not so open that your brains fall out. And I think that, we're in that moment where space is cool and space is exciting. And hopefully it'll help me sell copies of the book. But at the same time, we should not be credulous about science because we should be aware of the lessons that it teaches us. And that's not about going into outer space. That's about this planet and the stuff that's happening here. It's all wrapped up in the same kind of storytelling about how the universe really is as opposed to how you want it to be. But I do remember Emily Lakdawala, who of course worked for the Planetary Society, saying that you've got to go and look for life on Mars with robots first, because human beings are filthy, dirty meat bags, was her phrase, right? Something like that. We're just full of life. I mean, taking yourself there. And of course, the topics of planetary protection are studied very, very carefully, and some zones are probably less likely to have life than others and so on. But that's the topic which is of huge interest, right? Scientifically, is there life somewhere else in this solar system? That, to me, is far more philosophically interesting than can we put boots on it. There's different people believe different things here, but that would I'm sure there's a cartoon somewhere of arriving on Mars and the first boot crushes the only living thing on the surface of Mars. It's a metaphor, but let's find out first before we just assume these places are barren and empty and for us to exploit. Because that model hasn't worked out tremendously well on this planet in some way. It has that very strange dichotomy, right, between the hardcore, it's astonishing, because this is a trope in the book a little bit. You can't actually go to these places, many of them outside the solar system anyway. But it's astonishing that we have the technology, the telescopes, the missions, and the physics and the understanding of the universe to be able to tell those stories as if you were there. And yet, that for me is the universe I live in, but the universe of imprinting yourself on it and being, colonizing and expanding, I struggle to recognize that as a valid approach towards space exploration. And it's kind of unique to space. My molecular biology friends don't kind of have those same discussions, or chemistry. Space is both incredibly cool and interesting to people, but it certainly has a broad spectrum of opinions and attitudes about what it means as human beings.
Well, from Mars, we go out to Jupiter. And I feel like Jupiter is really interesting because it's almost like it's a miniature solar system all on its own with a whole suite of worlds. And maybe they give you a little extra leeway here because you go to more than two places in the Jovian system. But the Galilean moons were the first celestial bodies that we observed orbiting something other than Earth. And that was proof in Galileo's time that we weren't the center of the universe. And all these centuries later, they're still teaching us something about the diversity and just the dynamics of these planetary systems. But when you think about these moons in that context and reflect on that journey from those first revolutionary discoveries to what we know now, what does that bring to mind in your storytelling?
A few years ago, we had the celebration of the 400 years of the invention of the telescope. Galileo is, it's attributed to him, but of course, microscopes and lenses came together. He was the first one to exploit them in that regard, and certainly wrote his work down, which is important too. You got to publish. So you're kind of aware of that history, but then by the time I was in astronomy, the Voyager missions and the Pioneer missions had been before. We were going there for ourselves. So you tend to forget a little bit about that historical discovery. But I have friends who live in Florence in Italy, and of course there's an observatory at Arcetri in just outside Florence. And Galileo's house, which was where he was imprisoned effectively in house arrest for his struggles with the Catholic Church, it's available to go and visit. And so I remember I've been there several times, but one time a few years ago, I had that kind of cosmic vertigo moment of realizing I was in a room feeling essentially the walls, the damp, where Galileo had lived his life, and revisiting that connection. And in there's parts of the book which do go back into that historical aspect. What did we think these things were? As you say, that really important aspect about it being another system orbiting around something else, breaking the geocentric model. But the discoveries which have been made since, and some of them by accident, right? The discovery of the first volcano on active eruption by Linda Morabito, just sort of looking at the Voyager images thinking, is that another moon on the limb of Io? And no, there's a volcano there. And so these are discoveries in our lifetime, and some of them are my lifetime, and some of them are sort of so accepted now that Io has got desperately volcanic surface. And then you go out to Europa and Ganymede and Callisto, the other three, and they have enormous liquid oceans under their surface with icy crusts on top. I wouldn't say you take that for granted, but these are astonishing discoveries that we've made. And of course, with all the missions that have been to Jupiter and also Cassini-Huygens, of course, to Saturn, there's still so much to learn as well. And the thing which always amazes me, I made a diagram, not for the book, but for one of my scientific talks, where what would it look like if you put Jupiter's magnetosphere and you could make it visible in the sky? It's enormous. It's 500 million kilometers long. It would be a colossal structure in the night sky if you could see it with the naked eye. Yeah, so and just the cloud systems on Jupiter and the planet itself, we still really don't quite understand what's in the core of Jupiter. You're right. I was allowed to have more than a couple of places because it's the Jupiter system. I couldn't have more than two places on Jupiter.
Yeah, you could have included that red spot as one all on its own. But if we go out to the Saturn system, you do take the time to talk about Saturn's north polar hexagon as its own entity, which I love because it's got to be one of my favorite features in the whole solar system.
It's completely bananas, right? It's such a weird thing. And it's weird that we, in a broad sense, actually understand it now as well, right? Why this regular polygonal structure on a rotating, more or less spherical body, and the interaction of the winds with that rotation and the density of the atmosphere end up in this stable configuration. And then right at the very center of it, there's this astonishing cyclone. And you zoom in on that, and then you put the Earth, and it kind of disappears in the middle of that. The scale of these things is just astonishing. People kind of have this expectation in a way, and that space is kind of chaotic and a bit random, and to find a regular polygon on a pole of a planet is just astonishing. And yet we understand how it works as well, we think now. And this is, we avoided the sun, but, we've just recently begun to get pictures from the poles of the sun with the Solar Orbiter mission. We've never taken pictures of the poles at any decent angle before, Not saying we will find polygons there as well, but we don't really know, because Jupiter has all sorts of weird stuff going on with mini storms interacting in its poles, and Saturn has it differently at the two poles, and it changes as the axis. Because, from summer to winter, which is a much longer period on these planets as they go around the sun, you get stuff changing at the poles as well. That idea of seasonality is just as applicable everywhere else in the solar system.
You also take the time to talk about worlds like Enceladus, and I do love this search for life concept in here. We kind of passed over Europa and the under subsurface ocean on places like potentially Ganymede, but Enceladus is just such an obvious example of this because we got to fly directly through the plumes on that thing. I really hope that we get a follow-up mission someday to go see that thing more closely.
Yeah, so again, it's one of those sort of discoveries, that Cassini-Huygens made of flying through the plumes, and initially not with taking pictures, but actually sensing on board that, there were changes in fields and so on. And then the pictures, those beautiful pictures of those plumes rising from the tiger stripes. And, that idea that indeed you could fly through it and you can sample that there's water coming out, but also that there's silicates in there and there's other chemicals which indicate that the base of Enceladus's ocean is in touch with rock. And so if you can add in some liquid water, some minerals, and some heating from the tidal squishing and squashing of Enceladus, you've got all the ingredients potentially for life. And indeed, you say, we should go back. And that is the primary goal of an ESA mission, which is designed to go back to Enceladus. Now, we've got to raise money in Europe to do that. Hopefully, we can get partners from around the world. That was picked as a very high priority by a committee here in Europe to go back to Enceladus in a similar way that Dragonfly is hopefully going to go back to Titan, because Titan in the same system is just the other end of the spectrum, completely bonkers, the only moon with a dense atmosphere. And I was reflecting on this before. It's 20 years since we landed a probe on the surface of that thing. Wow. And for kids growing up today, who are at school today, it's in the history books. 20 years ago, it's a long time, but particularly when that mission was conceived and built and had to fly all the way to Saturn. We've done that. That's amazing that we landed a probe, the Huygens probe, on the surface of Titan. But it only operated for a short period, and we knew that we landed in this dry riverbed. And the images taken down through the descent showed, dendritic structures like rivers. And we know now from the Cassini data that it rains on Titan. And there are lakes and there are rivers, but none of it's water. It's ethane and methane. It's liquid hydrocarbons. So you have that. And then just across the way, so to speak, you have a planet with actual liquid water coming out from inside. Saturn, I was kind of prepared for the question, which is your favorite planet in the solar system? Saturn, in a way, because it has everything. And it has the rings as well, and the polar hexagon. And it has, the little moons in the rings. And it's what an amazing system Saturn is.
That Cassini-Huygens mission was so just unbelievable in the imagery it brought up. I still, anytime I'm really stressed out, and I think that's kind of what's beautiful about this book. Like whenever I'm feeling really burdened by the world, I go on this kind of mental travel journey to somewhere in space. And very frequently, it's something from Cassini. It's thinking about the surface of Titan, or just seeing that backlit Saturn with the rings. Those images are so iconic and beautiful, but there's so many other beautiful places to also think of.
Yeah.
Sitting around a pulsar, being on Io if you want a horrible time.
Yeah. And then, the small bodies, as we're going out through the solar system, we shouldn't forget the solar system is full of lots of little bits and pieces as well, right? All the asteroids and the comets and everything else. What a place to visit, right? We live in the middle of it. It's amazing.
Well, we at least had a few, opportunities to see Saturn. But if we move out to Uranus and Neptune, we have literally only flown one mission by them in the history of humanity. Did that make it any more challenging to try to pick places on those worlds to talk about?
No, I think it's a topic constantly that arises in strategy for the US science community, for the European, and of course these are very interlinked, Uranus and Neptune, we flew past with Voyager 2, and that was it. And I remember being at a meeting, again, about 10 years ago, where Ed Stone, who was the PI for the Voyager missions, somebody asked him a question, which you intuitively know the answer to, but he just phrased it so beautifully. He said, so how come we managed to get to those, we haven't gone back yet, and we got to them so quickly the first time? And he just said, because we didn't stop. It's easier to fly on a direct trajectory, just like New Horizons did. But if you want to match the velocity of going out to Uranus or Neptune and go into orbit around it, it's a much longer journey. Because it probably involves flybys or very large rockets and then cruising up alongside these bodies. It's a very interesting topic, I think, as well, about the ambitions of humankind with respect to space, because any mission that is going to go back to Uranus or Neptune is going to be very long. It's going to take a long time to get there. And the money that's allocated for space science, which is large sums of public taxpayer money, so there are committees discussing what's the best thing to do at a given moment, there's always going to be that tension that if I'm going to put, let's make a number up, $1 billion, whatever currency, and I'm going to put it into a mission, and it's going to take 25 years to get the science back from a mission to Neptune, say, an orbital mission, versus launching an observatory that goes somewhere to L2 like JWST is, and you get data back in 6 months' time. So making that commitment, and also developing the technology will last long enough, and all the nuclear power questions once you're far away from the sun. There's an enormous pressure from the science community, rightly, to go back to Uranus and Neptune. And the key reason, if you like, not just in and of themselves, but we know that many stars in the Milky Way have planets like Uranus and Neptune around them. And so we should understand our own to hope to understand those planets around other stars. And there's a lot of momentum, but it feels to me, and people like Heidi Hammel and others will shout at me for saying this, it feels like there isn't quite enough momentum and political willpower and everything else to do it. And yet, we're talking about the species, for good or for bad, that built cathedrals that took long lifetimes. We made these things for reasons, not the same reasons, but we committed to long-term projects because we saw the value in something that I would never see during my lifetime, but the next generation will. And we should do that. We should do those projects because they're important for us as to who we are as human beings. We should build these cathedrals, if you like. And the fact that it might take 20-something years to not only to build it, but then to get there, we should do it. And we have done amazing things like that. The Rosetta mission, right? 10 years in flight to get to its destination.
I love the Rosetta mission so much. And I'm not just saying that because you worked on it. Those images of just stuff, just particles kind of floating around. When you put all the images together in some situations, people have tried to stitch together these short videos of what was happening on that comet as it was outgassing and other things. It is just breathtakingly beautiful.
Yeah, you're right. I was lucky enough to be involved. The mission preceded me, of course. It was launched before I even joined ESA in 2004. But through my job as being head of the science department, I had the project scientists, and so I was working with the science teams at my level to support them to get the science out, but also the communications and outreach. And I think that we managed to do something very special with the Rosetta, with cartoons and science fiction films, and the public were just really into it. This kind of happening in real time adventure. But yeah, that particular thing you're referring to, that one particular movie was put together by one of the people on, in the community, and took the data, which were public at that point, and reoriented the data. No cheating, but basically said, well, if I turn it this way, there's no particular orientation in space. Why not? So the movie that he made shows the comet from a distance, rotating slightly. There's lots of stuff in the foreground. And then it looks like snow falling on the comet in the background. But it's not. It's stars in the background moving as the comet and the spacecraft are moving. And so when I first saw that, I thought it was beautiful, just like you did, incredibly evocative. Everybody said, snow falling on 67p. But I just went back into the archives, pulled out the images, and I identified the stars using one of the astrometry.net, one of the tools. But it very quickly became apparent that it's an optical illusion which is beautiful and charming. And it didn't get misused, let's put it that way. Like the face on Mars we were talking about before, where that then became a whole agenda of NASA hiding the fact there are aliens on Mars. This was just something which people got engaged with I remade it myself because when it's on social media, it was low res, kind of a low res GIF. And it's beautiful. I mean, I have the high res version of it. It's amazing.
These missions impact us all so deeply. And these are beautiful things that we want to see done for the betterment of humanity, which is why I'm glad that there are things like this book that helps make it more accessible for everyone. Because, the things that have been accomplished, the sheer scale of everything we've done and all the people that you've mentioned along the way that were a part of this is something that we need to let other people know and make it feel like they're part of this journey as well. Because, my gosh, the things we've accomplished, everyone deserves to know these things.
Yeah, and I think that's absolutely right. And I think it's also important. It was important for me writing the book, even though it was costing me words, it's, because it's a very strict format. So, the letter count is very rigid. I would put in that this is what we currently believe, or this is what we think is happening, rather than it just is. Because that's, things will turn over. I mean, I was constantly in fear that the book was just going to keep changing as I was writing. And it did. And I had to keep editing things and just draw a line at some point. So I'm not looking at any. So since the book has been printed, we now know, for example, that quite possibly Andromeda and the Milky Way may not collide. Sorry, the book says that they probably will. So, I can update that. But that's the beauty of it, is that we are constantly discovering new things. So rather than it being set in stone, this is the way the universe is. Hopefully, there's a bit of an investigation or an idea in the book that we're learning things as we go along, and come back and, follow us and join in, because they're your missions. You've paid for them, right? And using a cartoon to engage, or as we did on Rosetta as well, a science fiction film, or allowing, not allowing, but the people going in and digging out the images and then making their own thing out of them. It's utterly essential, not only because I think it's exciting, but because the public paid for all of this stuff, right? And I'm immensely privileged to be lucky enough to do this for a living. But I try not to ever lose sight of the fact that this is because society has decided in some grand way that curiosity and art and culture and exploration are things that are part of who we are.
We've talked about just the smallest part of this book. It goes so far beyond into other places in space, but we'll leave all that for the readers to get into if they want to explore the rest of the universe. I really loved the way that you laid out this book, and I'm hoping that it brings on a whole new group of people that didn't expect to be picking up a tour guide to the universe while they're trying to explore some other location on Earth. So I'm really hoping that people find this book and use it as a new way of opening up the universe to themselves, because there's so much to be seen and to talk about, and we've only just touched on a small little bit of it. So thank you for doing this work.
Yeah, no, it's a great pleasure. Thank you very much for allowing me to talk about it.
Really, though, there are so many cool locations in this book that we did not get even a slight chance to talk about. I'm particularly fond of some of the giant cliffs they talk about and base jumping in space, but I'm going to leave that up to you if you want to learn more. Before we wrap up, it's time for What's Up with Planetary Society Chief Scientist Dr. Bruce Betts. This week, we're celebrating Bruce's brand new books in our children's series with Lerner Publishing Group. The first one is called The Size of Space, which is out now. It takes the mind-boggling scale of our solar system and tries to make it easy to understand for young learners. The other one, which is called Are We Alone?, comes out on October 7th. It gets into one of humanity's biggest questions. Is there life beyond Earth? I know I asked that question a lot when I was a kid. Together with the rest of the books in the series created by the Planetary Society, they're designed to spark wonder and curious young minds, the very explorers who someday are going to carry on our mission to explore worlds, find life, and protect our planet Earth. Hey, Bruce.
Hey, Sarah.
So I feel like, we talked about a book this week. Last week, we talked about our coworker Kate Howell's new book about moons. And you, too, are another member of staff that is coming out with new books. And you have been for quite a while. You've been working on this series of kids' books for the Planetary Society. Are you excited that you've got two new out? Or at least...
Oh, I'm very excited.
Yeah, you've got one that's going to be out by the time people listen to this episode, but the other one is going to be out in October.
Right. So, no, it's very exciting. I've been working for a while now with Lerner Publications, who focuses on children's books, and particularly for school libraries, but also you can buy them on Amazon or at their Lerner site, and it's through the Planetary Society, and we worked out things with them. So I had one for the eclipse, and 12 for different objects in the solar system. 12, 13, something like that. And then now we've got two that take on things in a different manner, kind of finishing off the series. And so coming out, or out by the time this airs, is The Size of Space, Measuring Our Solar System with the Planetary Society. So largely it's some of the really fun, groovy, interesting, or insightful scale random space fact type things of like how big is, particularly focusing on the solar system, one thing relative to another, and to try to start wrapping brains around how ridiculously huge things are, like, the sun and Jupiter, and then what distances are. Yeah.
Is it limited to within the solar system, or do you try to give them an existential crisis by taking them out to the size of the universe?
No, I was going to have an existential crisis spending too much time beyond the solar system. That's why I'm a planetary scientist, unlike people like you who go out deeper. It just scares me out there. But there's a little coverage. It's mostly solar system and comparison of sizes and surface areas and distances, and trying to get a feel for it, and as much as you can in comparisons to things we're used to. And so there's just kind of a sweeping arm waving statements late in the book to give an idea that this is only the beginning, and if you think this stuff's weird, there's a whole lot more out there beyond it. Speaking of weird, the next book, Are We Alone? Searching for Life Beyond Earth with the Planetary Society.
Man, I would have loved these kids' books if I was tiny. Like, this is exactly the kind of thing that would have blown my mind as a child. It seems like a lot of fun to write these books, honestly. Like, I know it's a lot of work, but what beautiful topics, and what a cool thing to try to explain to kids. What is the age group that these are targeted at?
Roughly your age.
Eternal children.
Plus or minus 40 years. No, it's targeted towards kind of U.S. 2nd to 4th grade, so kind of 7 to 10 age, 7 to 10, 7 to 11. But hopefully they're also interesting to your eternal and other eternal children out there.
I love this about you. It's this is funny to say, but like, you have this curmudgeonly exterior, but I think underneath that, the fact that you spend all this time writing these wonderful kids' books really reveals who you are as a person, Bruce, in the best way.
That's classified. I can neither confirm nor deny this outrageous statement you've made.
Well, I know people can buy these books personally, but I know as well that they can recommend that their local libraries put these books in, right? So if people want to learn more about how they can get these as resources for their students or at local libraries, what should they be doing?
We'll have some write-up on this. We have a page on our website updated with these books. And also you can go to the Lerner site, which is Lerner. They have a lot of insight into getting it into particularly school libraries. But yeah, if you see these, if you're interested, if you like them, please do recommend them to local libraries or school libraries for incorporating them. And one other favor, if anyone reads these with your kids or just yourself, and you are willing to write a quick review on Amazon, that seems to be critical to their algorithm, noticing the books and actually letting people know they exist going forward. So not only good for us and Lerner, but I love getting these books out in the hands of kids and getting them excited about space so they can grow up and be a curmudgeon about space.
Well, you heard the man. Go out there and write comments on these books, because honestly, they're beautiful. I've gotten to see them around the office, and it's such a lovely book series. And I hope it opens up the solar system and even wider subjects to a whole new audience, because these kids deserve to be inspired. There's so much beauty out there to learn about. Well, anyway. Oh, is that the launch failing?
No, that was crashing into the moon, which is something that the Soviet Union did with Luna 15 a probe designed not to crash into the moon, but that did it on the same day, or at least during the same 24-hour period that astronauts first walked on the moon. I just thought it was interesting that while astronauts are walking over here we actually discussed this before, in the Sea of Tranquility, they were crashing into the Sea of Crises. I mean, sometimes you got to pay attention to those words before you design things. I mean, never stay at a campground that is called, next to Spider Lake. I mean, it's not going to work out.
That's super funny. And even funnier knowing they didn't do that on purpose.
So there you go. There's our fun for the for random space fact. Well, I mean, not fun for the people working on that mission, but everyone was kind of focused on other stuff. So
sometimes you got to crash into the moon. It happens.
Wow. Wait, I hope someone takes down great quotes from you in this show. Sometimes you got to crash into the moon. It happens.
It happens.
Says no person who's ever been involved with a lunar mission that wasn't designed as an impactor. Some of them are designed to crash into the moon on purpose, but not very often. All right, everybody. This has been fun. So everybody go out there, look up in the night sky, and think about the prettiest bird you've seen in the last week. Thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week with more space science and exploration. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. I'd love to know what location in the solar system that you'd take a vacation to, assuming you could survive the journey. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members all over the world. You can join us as we work to share this amazing interplanetary adventure at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition, and Matt Kaplan hosts our monthly Book Club Edition. Book Club comes out this next Friday, so keep an eye out for it. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. I'm Sarah Al-Ahmed, the host and producer of Planetary Radio. And until next week, Ad Astra.